And now let's do another example on an optimization problem. And this problem is a good problem that's suitable for students who are in business major. And so, but viewers or students who are viewing this video outside of the business major are more than welcome to view and learn from the video as a general method for how we find the maximum and minimum value problem in an optimization problem. And but of course, outside of the business major, then maybe viewers have to spend a little time trying to understand what these functions, the cost function and the revenue functions are. Okay, so let's get started to it. And so the wording says the pair company sells P phones, and the cost to manufacture X P phone is given by C of X equals minus 30X squared plus 49,000X plus $21,724. So this is the cost for here, and this includes overhead cost and production cost for each P phone. And so overhead cost and production cost are just different ways of calling fixed cost and variable cost. And so now continuing into the problem right here, into reading the problem, if the company sells XP phones for the maximum price they can fetch, the revenue function will be R of X equal minus 35X squared plus 169,000X dollars. And so now the ultimate question now is how many P phones should the pair company produce and sell to maximize a profit? Okay, so as I said earlier, that this problem is particularly suitable for students who are in business major, simply because students in business major are a lot more familiar with these functions, the cost functions and the revenue functions that I'm highlighting here. But outside of the business major, viewers outside of the business major can just spend a little bit of time extra to learn about the cost function and the revenue function. That's it. But now I have to be clear that according to the two functions given here, they are not our objective function yet, because see, when we read the ultimate question here, how many P phones should the pair company produce and sell to maximize profits? Maximize profit. So this highlighted phrase right here, this highlighted information right here, indeed rings for us a bell that our objective here of the problem, of this problem here, for our objective, we want to maximize profits. Okay, that's our goal, to maximize profits. But profits was not given in the problem itself. The problem gave us cost function and it gave us revenue function, but it did not give us the profits. And so now we are going to spend some time identifying our profits as the objective function right here. So we know our goal is to maximize profits, but let's come up with our objective function. And so let me write down the information we've had on the board here. We've had on the computer screen earlier. So cost, including overhead and production cost, is going to be minus 30X squared plus 49,000. Maybe let me write it in a different space. So cost, C of X minus 30X squared plus 49,000X plus 21,724. Okay, so that's our cost function. And our revenue function is minus 35X squared plus 169,000X. So as I said earlier, students in business major should be familiar with the revenue function. and cost function. And in this particular problem, we have both of these functions given. But our objective function is the profit, which is not given in this problem yet. But so students who are in business major are well aware of how to derive, how to find the profit, because it's always profit is revenue minus cost. So in that way, and that's just a reminder, profit will always be revenue. I'm using the shorthand notation, or EV for revenue, and minus the cost. That's just the way it is. That's how we make business. We spend, this is our own expenses. That's for cost. And then we make money by selling away the product. So total revenue subtract the cost, that gives us the profits. Simple concept right there to understand. But so in that way, algebraically, our profits function as a function of x. And of course, x here is going to be the number of p phones. So that's some quick meaning of our variables right there. So p of x must be revenue as a function of x, the number of p phones that the company is selling, minus the cost function. And so in that way, I'm looking at minus 35x squared plus 169,000x. This is for revenue, and I'm subtracting away minus 30x squared plus 49,000x plus 21,724. So revenue minus cost. And I ran short of line, so I wrote that last term of my cost function kind of down below right there. So that means all together here on my other board, we're looking at, and we can algebraically remove the parentheses. So minus 35 x squared plus 169,000x plus 30 x squared and minus 49,000x and minus 21,724, because the minus sign the minus sign here was responsible for switching all the signs that happened after we took out the parentheses. And that's how you saw I switched the signs in the other board. So now we're going to combine like terms to come up with our, so this is already our profits function, but we want to algebraically simplify it down a little further by combining like terms with things like this. Combining like terms is the last thing we can do right there to make our final function a little shorter. Okay, so these two are like terms, those two are like terms. So now I'm looking at minus 5x squared plus 120,000 x, and now minus 21,724. Okay, so now, ladies and gentlemen, this is our final objective function. And yes, it took a little bit of work to find our objective function, which is a very usual thing when anytime we're doing an optimization problem. Sometimes the objective function is simply given, and all we do is just get immediately on it and get it done. Sometimes we have to spend some time finding and deriving our objective function. Okay, so this is our objective. So our objective function is here. So I'm going to leave that here on the board, on my left board here for a little while. Okay, and that's our objective function. And really, we don't have any, because anyone have seen on the computer screen earlier the wording here of the problem, and the problem did not really give us any. If we read throughout the whole problem here, there was nowhere in this problem that's giving us the constraints of the problem. So in other words, this problem has no constraints. We don't need to have any constraint for this particular problem. So I am now going to make some space, and then now once we have identified our objective function, we are going to get straight into doing the calculus work to find to maximize our profits function. And it is a function in terms of the number of p phones being sold. So now at this point, I have some opportunity to write down the meaning of the variable. Here, x is the number of p phones here, the number of p phones that are sold by parent company. All right, and so and as just a standard step, as a standard work right here, first step into finding the maximum or minimum problem of a found objective function, we are going to take the derivative of our objective function. And in this case, it gives me minus 10x plus 120,000. Okay, so that is our the derivative of our objective. And so with this derivative, once again, the next step is to set our derivative equal 0 as a purpose. We want to find, by doing this, we're going to produce for ourselves the following equation: minus 10x plus 120,000 equals 0, and which eventually, after solving this, will give us the critical value of our objective function. All right, so back on this board right here, minus 10x plus 120,000 equals 0. I'm going to subtract 120,000 from both sides, and that leads me to minus 10x equals negative 120,000, and dividing both sides by negative 10. So anyone viewing this video is expected to be in calculus, who, you know, at some level of calculus. So you should be familiar with any of these steps that I'm doing for the algebra, solving the equation. So our final equation here, our final value of x that we're solving for, is going to be, okay, positive 12,000. Okay, so just now we found x equals 12,000, and it means this is the number of p phones that the parent company should be selling. But so far at this point, this is only our critical value. And again, in some video lesson, I remember to emphasize, in some video lesson I might have forgotten, but this is just, it's only, this value that we found is only a critical value. So I put it in a box here just simply to, you know, trigger your attention, but it's not the final answer here yet. This is only a critical value, because at this value, at this number of p phones, our profit can be at the maximum, or our profit can also be at the minimum. So, or it can be neither. And so in order to test, I am going to use a test to decide whether this critical value is going to give us a maximum or a minimum. And again, in my experience, I am going to stay with the second derivative test for this, because again, because our function here, our objective function, is a simple quadratic right here, and then we already had the first derivative, and the second derivative is quite easy to find, even though we haven't found it yet, but the second derivative is quite easy to find. And then going with the second derivative test here, it can save us all that effort from constructing sign charts and all that. Even though any other users any other viewers watching this video, you are more than welcome to do your own constructing sign chart, or in other words, the first derivative test, and it should turn out the exact same result, even though it might take a slightly longer route. I'm not saying it's always like this, but it just happened to be that in these problems, in my experience, I've seen that, you know, doing the second derivative test is going to be arriving at your decision a little faster. Okay, and so now I am going to get back to my other board and erase some finished work. I want to retain the other information. So now this solving work for critical value, I can erase that out. And so now we found critical value to be 12,000. Our second derivative, p prime of p double prime of x, is going to be, in this case, let me quickly bring up the other board one more time right here. So this is our p prime. So p prime is minus 10x plus 120,000. So in that case, p double prime is going to be minus 10. Okay, and so now to check for whether our critical value here would give a maximum or minimum, I am going to substitute this critical value into the second derivative. So p double prime at 12,000 is the same as that constant negative 10, which is a negative value. Okay, and so anyone who is a little bit unsure about why this work is going to give me, so well, the conclusion we have here is that the p of x, our profit function, has its maximum, okay, at this critical value x equals 1200. So now we're concluding that at this critical value we produce a maximum value for our p of x function. And so back to what I was saying in the middle earlier, and I have to kind of chop away and turn direction, but anyone who is unfamiliar with this, then I have earlier video lectures showing how to apply, how to use the second derivative as what's so-called a second derivative test for that. So I highly recommend rolling back and review that video about how to use, or the idea of the second derivative test to well understand how this inequality, how this comparison with zero lead to saying that we have to have a maximum at our critical value. Okay, but here all I can do is all I can explain is to take that derivative, take that step as the step of the work, and then come to our conclusion here. So now, but that all of a sudden here, we realize we have found our first answer. And actually that is the answer for our work right here. Because here, back to the computer, the wording under the problem said, how many P phones should the parent company produce and sell to maximize profits? Okay, and so in that way, right here in our problem, we have found that. So we don't need to go any further. We have found the answer. When the company is selling 12,000 P phones right here, then that's when it makes its maximum profit. Okay.